The engine screamed like nothing the sky had ever heard before. High above the Pacific, a prototype fighter tore through the clouds at impossible speed, its propeller biting into thin air, its frame trembling under raw, unrestrained power. Below, the ocean shimmered in silence. But up here, the sky was at war with the machine itself. Control, this thing's running too hot. She's not built for this. The radio crackled, then dissolved into static. Black smoke trailed behind the aircraft as it pushed past limits no pilot had dared approach. Gauges rattled. Oil pressure surged. The engine, massive, experimental, almost uncontrollable, was delivering power far beyond anything deployed in combat. And yet, this wasn't a victory. Because despite its unmatched strength, despite being capable of outperforming nearly every aircraft of its time, the U.S. Navy made a decision that would shock engineers, frustrate pilots, and quietly change the course of aviation history. They refused it, not because it failed, but because it was too powerful, too dangerous, too far ahead of its time. This is the story of the most powerful engine ever built during World War II, the aircraft that was meant to dominate the skies within the reason the Navy chose to walk away from a machine that could have rewritten air combat forever. By the early 1940s, the war in the Pacific had become a brutal contest of endurance, engineering, and air superiority. Aircraft were no longer just machines. They were lifelines, weapons, and symbols of dominance over vast, unforgiving oceans. Carrier decks had become floating runways of life and death. Every takeoff mattered. Every landing was a gamble. And in this high-stakes environment, power meant survival. The faster you climbed, the sooner you could intercept. The stronger your engine, the heavier your payload. The more durable your aircraft, the greater your chances of returning home. But power came at a cost. And no one understood that better than the engineers pushing the limits of aviation technology in wartime America. Deep within experimental facilities, far from the front lines, a new kind of engine was being developed, one that dwarfed its predecessors in both size and capability. It wasn't just an upgrade. It was a leap, massive displacement, multi-row radial design, extreme horsepower outputs that pushed well beyond operational safety margins of existing airframes. On paper, it was revolutionary. In the air, it was terrifying. The aircraft chosen to carry this engine was already ambitious, designed to dominate the skies with speed and firepower. But once fitted with this monstrous power plant, it became something else entirely. A beast. Test pilots described the experience as fighting the aircraft just to keep it stable. The torque alone could twist the plane during takeoff. The heat generated pushed cooling systems to their breaking point, and any minor mechanical flaw could escalate into catastrophic failure within seconds. But when everything worked, nothing could touch it. It climbed faster than interceptors. It outran threats that would have shredded conventional fighters. And in theory, it could have given the U.S. Navy absolute air superiority in critical phases of the war. So why reject it? Why turn away from such overwhelming advantage? The answer lies not in its power, but in its consequences. Because in war, the best weapon isn't always the strongest one. It's the one that can survive long enough to be used. The cockpit rattled as the throttle edged forward, just a fraction more, and the entire airframe responded like a living thing under strain. The propeller blurred into invisibility. The noise wasn't just loud, it was violent, a deep mechanical roar that pushed through the pilot's chest, through the controls, through the very structure of the aircraft itself. Below 10,000 feet, the engine already felt unstable. Above it, it became unpredictable. Temps rising, this isn't sustainable. The pilot eased back, reluctantly surrendering speed, because every extra second at full power felt like gambling with an explosion. That was the paradox. This engine could win any chase. It could outrun danger, outclimb interception, outpower anything sent against it. But it couldn't be trusted to hold together long enough to matter. And in war, trust isn't optional. It's everything. By 1943, the United States Navy was locked in a relentless struggle across the Pacific theater. Carrier-based aviation had become the backbone of naval warfare, with aircraft like the F-6F Hellcat and F-4U Corsair proving decisive in securing air superiority. But the war was evolving. Enemy aircraft were improving. Missions were becoming longer, payload demands were increasing, and the need for speed, especially during interception and escort missions, was critical. Engineers knew that incremental upgrades wouldn't be enough. They needed something revolutionary. And that's when development began on one of the most powerful piston engines ever conceived, the Pratt Whitney R-4360 Wasp Major. 2 technical advantages. The R-4360 wasn't just powerful, it was monstrous. With 28 cylinders arranged in 4 rows, it produced over 3,000 horsepower, far surpassing most operational engines of the time. This meant faster climb rates, higher top speeds, ability to carry heavier armament and fuel loads, extended range for deep strike missions. Aircraft equipped with this engine could theoretically dominate both interception and ground attack roles. On paper, it was the ultimate advantage. But in the air, physics pushed back. The immense torque created stability issues, especially during carrier takeoffs. Cooling such a large engine proved extremely difficult, particularly in the hot, humid conditions of the Pacific. Maintenance crews faced constant challenges just keeping operational. And worst of all, reliability was inconsistent. 3. Combat story/operational reality. During test flights and limited operational trials, pilots reported both awe and fear. One naval test pilot described a high-speed climb where the aircraft reached altitude faster than anything he'd flown before. But within minutes, engine temperatures spiked dangerously. Oil systems struggled to keep up. Vibrations intensified, and the aircraft had to be throttled back or risk total engine failure midair. In simulated combat scenarios, the aircraft could outrun threats, but only for short bursts. Sustained performance? Uncertain. And in real combat, uncertainty kills. 4. Enemy perspective. Had this engine been fully deployed, enemy pilots, particularly Japanese and later German interceptors, would have faced a nightmare. An aircraft with unmatched speed and climb could dictate every engagement. Boom and zoom tactics would become devastatingly effective. Interceptors would struggle to catch it. Bombers escorted by such fighters would be far more protected. But fear alone doesn't win wars. Consistency does. 5. Strategic impact. The Navy ultimately faced a hard truth. Carrier operations demanded reliability above all else. Aircraft had to launch quickly, land safely, and be maintained efficiently under harsh conditions. The R-4360 power designs failed that test. They were too complex, too unstable, too demanding. So instead, the Navy doubled down on proven platforms, refining existing aircraft that balanced power with reliability. And in doing so, they chose practicality over raw dominance. There was also the issue of logistics, often overlooked but decisive. Carrier crews operated under constant pressure, with limited space, limited tools, and no margin for error. The R-4360 demanded precision maintenance, frequent inspection, and specialized knowledge that simply didn't exist at scale during wartime. Turnaround time between missions increased. Failure rates, even if small, became unacceptable in combat conditions. And then there was fuel consumption. At full output, the engine burned through fuel at a rate that reduced operational efficiency, limiting mission duration unless additional fuel was carried, adding even more strain to an already overburdened system. In controlled environments, it was extraordinary. In war, it was impractical. In the end, the most powerful engine of its time never became the dominant force it promised to be. Not because it lacked strength, but because war doesn't reward extremes. It rewards balance. The R-4360 would go on to find life beyond the battlefield, powering massive bombers and transport aircraft in the post-war era. In those roles, its power could finally be harnessed without the brutal constraints of carrier warfare. But during World War II, it remained a glimpse of the future that arrived just a little too early. The Navy's decision wasn't a failure of ambition. It was a recognition of reality. Because in the chaos of war, on pitching decks, under enemy fire, with seconds to react, there is no room for unpredictability. Pilots didn't need the fastest aircraft. They needed one that would start every time, take off every time, bring them home every time. And that is why the most powerful engine ever built was left behind. History often remembers the machines that won wars, but just as important are the ones that didn't. The prototypes, the experiments, the ideas that pushed boundaries but couldn't survive the harsh test of reality. The R-4360 was one of those ideas, a symbol of what was possible and a reminder of what was practical. In another timeline, perhaps with better materials, improved cooling systems, or more time, it might have reshaped aerial combat entirely. It might have dominated the skies. It might have changed outcomes. But war doesn't wait for perfection. It forces decisions in the moment. And those decisions, practical, grounded, sometimes conservative, are often what truly shape victory. The pilots who flew reliable aircraft, the mechanics who maintained them under impossible conditions, the engineers who chose stability over risk. They were the ones who carried the war forward. Not the most powerful machines, but the most dependable ones. And yet, there's something unforgettable about that engine. The roar, the ambition, the sheer defiance of limitation. It represents a moment in history when humanity reached beyond what was safe and touched what was possible, even if only briefly, even if only in test flights and forgotten reports. Because sometimes the greatest innovations aren't the ones that succeed. They're the ones that show us how far we can go, and how far we're willing to risk everything to get there. Even today, aviation historians look back at the R-4360 with a kind of quiet respect, almost reverence, not because it was widely used in combat, but because of what it represented. It was the peak of piston engine ambition, the absolute limit of what engineers could extract from mechanical design before the jet age took over. And perhaps that's why it feels so significant, because it arrived at the edge of an era, just before everything changed. Within a few years, jet engines would redefine speed, altitude, and air combat entirely. The brute force complexity of massive radial engines would give way to smoother, more efficient propulsion systems. In that sense, the R-4360 wasn't just ahead of its time. It was a final chapter of an entire technological philosophy, one last attempt to push propeller-driven flight beyond its limits. And it succeeded, just not in the way anyone expected. It didn't dominate the battlefield, but it proved those limits existed. And once they were reached, the future had no choice but to move beyond them. IT wasn't the engine that won the war, but it was the one that proved just how powerful the future could be.